Alright, so guys, now we have to find the derivative of 2x minus 1 root x square plus 1. And you can see that I cannot simplify this equation any further. So I would simply apply the derivative over here and then I would see how our question is going to proceed. X square plus 1, and remember, wherever there is a root, I can actually write power 1 by 2. Okay, let me just write it in this form: 2x minus 1 divided by x square plus 1 power 1 by 2. All right, now you can apply the rules of division for the differentials. So this is my fx in the numerator, this is my gx in the denominator. So what I can actually do, x square plus 1 power 1 by 2 d by dx, 2x minus 1. Okay, this is the first function, minus the first function 2x minus 1 multiplied by the derivative of the second function. What is the second function? X squared plus 1 power 1 by 2, and in the denominator we have x squared plus 1 by 2 squared. Okay, now let's continue. X squared plus 1 by 2. What is the derivative of 2x minus 1? All right, so d by dx, 2x minus d by dx, 1. So this would actually be 2 and this would be 0. Okay, how did I figure out that this would be 2? You can see that this is the constant, so constant multiplied by any variable would actually become at the first, then d by dx. So x are cancelled. What is remaining? 2 times 1 is actually 2. This is the derivative, so 2 minus 2x minus 1, and now x square plus. Okay, now let me just focus on this derivative for a while. Okay, in my previous video, I have explained you the concept of the derivative of the angle. And if you are not sure what is the derivative of the angle, you can watch that video. So you will be much more clear what was happening over here. Okay, now let's see. This is the power. So 1 by 2 x square plus 1 upon 2 minus 1. This is according to the rule. Now we have to multiply this thing by the derivative of the angle. Now what is the angle over here? The angle is the thing which is present inside the bracket. So that is x square plus 1. All right. Now let's just continue. 1 plus 2 x square plus 1. That is negative 1 by 2. And what is over here? So this would actually be d by dx, x square plus d by dx, 1. Now the derivative of any constant is actually 0. So this would be 0. So the power, then the x. So this is 2x. Now you can see that the 2 and the 2 are being cancelled. Remember, everything is being multiplied over here. Okay, so you can actually cancel those out. Now what is remaining? X square plus 1 power 1 by negative 1 by 2 and x. Okay, right, so x square plus 1 negative 1 by 2, and in the denominator we have these twos are cancelled, so x square plus 1. Now x square plus 1 by 2 minus. Now we actually have to simplify this thing first of all. So you can see that this is in the negative form, right? So I can put it in the bottom of 2x minus 1. Okay, 2x minus 1 divided by x square plus 1. Okay, 1 by 2 and x divided by x square plus 1. Now I can take an LCM over here. So in the numerator, remember, this is our numerator and this is our denominator. Don't get confused with this thing over here. Okay, so we are going to take x square plus 1 power 1 by 2 as our common LCM. Okay, so x square plus 1 power 1 by 2. So if you're taking an LCM of something, what would actually happen? You would multiply the x square, this term, by every term present over here, right? So x square plus 1 by 2. I'm writing this term, okay? 2. Then this in the denominator, actually we are taking LCM. So we have to multiply this thing right over here. Okay, so 2 x square plus 1 plus when the bases are same, the powers are added. What is the remaining? X square plus 1 plus 1 upon 2 plus 1 upon 2 is actually 1. So this is the remaining x square plus 1. And over here, if you focus on it, this is actually having x square plus 1 power 1 by 2, right? So I can simply cancel. How? Just see over here, 2x minus 1, right? X, okay, x square plus 1 by 2. This is the requirement of taking an LCM, that you have to multiply the term in the denominator by everything present in the numerator, right? And in the denominator of this term, we are having what? X square plus 1 power 1 by 2. So this would be cancelled, and what would remain? 2x minus 1, x. So what would be written over here? It would be x, 2x minus 1. Got it? Now let's just move on. 2x square plus 2 minus. Now see over here, x squared 2 minus minus is actually positive, right? And x times 1 is x. So this is the final. We can cancel these things, and in the denominator we have x squared plus 1 by 2. And yeah, I completely forgot that we were having an actual denominator that was x squared plus 1. Okay, so you have to be very careful while solving for the differentials of such complex functions. Okay, and now what is remaining? 2 plus x squared plus 1 by 2, and this thing is actually x squared plus 1 power 1, right? And I can multiply this thing, the denominator of the numerator by the actual denominator of the function, right? So what would happen? It would get down and it would be negative. So x squared plus 1 power 1. Okay, let me just explain it again. If we are having a denominator in the numerator, you can actually multiply that denominator by the actual denominator present in the bottom of the whole equation. Okay, and if you are taking something down, of course you are taking the reciprocal, and if you are taking the reciprocal, the signs would actually change. So if it is having positive over here, it would become negative when it would be multiplied by the actual denominator of that equation. Okay, so when the bases are same, the powers are again added. 1 minus 1 by 2 is actually 1 by 2. So this is our final answer, 2x plus x squared plus 1 by 2. And I hope that this question makes sense. And if you enjoyed the video, please consider subscribing our channel. Okay, thank you.